Good afternoon, everyone. Good afternoon, Ma'am Cheryl Dublar. We are the group two, and we're going to present about the topic data, information, and knowledge.
Defining data. What is data? Data is a collection of details or data remaining in the form of either figures, text, symbols, descriptions, or mere observations of entities, events, or things with the potential to be analyzed, drawn inference from. They are raw, which requires rendering to acquire meaningful information. Data has various forms like letters, numbers, images, or characters. Computer data, for instance, is represented in the forms of zeros and ones that can be interpreted to the form a fact or value. The measuring units of data are Nibble, bytes, kilobytes, megabytes, gigabytes, bytes, terabytes, petabytes, etc. Types of data. There are two types of data. Primary data, quantitative, which is divided into quantitative data and or qualitative data, and secondary data, which is divided into internal data and external data. The types of data is ordinal. These types of values have a natural ordering while maintaining their class of values. If we consider the size of a clothing brand, then we can easily sort them according to their name tags in order of small, medium, and large. The grading system while marking candidates in a test can also be considered as an ordinal type where A plus is definitely better than the B grade. These categories help us decide which encoding strategy can be applied to which type of data. Data encoding for qualitative data is important because machine learning models can't handle these values directly and needed to be converted to numerical types as the models are mathematical in nature. For nominal data type, where there is no comparison among these categories, one hot encoded can be applied, which is similar to binary coding considering there are less numbers of n for the ordinal data type. Label encoding can be applied, which is a form of integer encoding. Quantitative data type is a type of data that tries to quantify things and it does considering numerical values that it makes it countable in nature. The price of a smartphone discounted offer number of ratings on a product, the frequency of processors of a smartphone or RAM that of that particular phone, all these things fall under the category of quantitative data types. The key thing is that there can be an infinite number of values a feature can take. For instance, the price of a smartphone can vary from X amount to any values and it can be further broken down based on fractional values. Discrete. The numerical values of which falls under the integers or whole numbers are placed under this category. The number of speakers in the phone, camera scores in the processor, the number of SIMs supported, all these are some sort of examples of discrete data types. Continuous. The fractional numbers are considered as continuous values. These can take the form of operating frequencies of the processors, the Android version of the phone, Wi-Fi frequency, temperature of the cores, and so on. This is the table of the types of data and their subcategories.
Defining information. A definition of information should capture the essential nature of the information phenomena in a precise description, while making explicit the similarities between information phenomena and other related concepts such as meaning, certainty, or knowledge. At the same time, it should bring forward the differences between these concepts. For example, in what senses does information move through time or space? How is information similar to knowledge, and how do they differ? The nature of information may be brought forward through the use of metaphor or a model. For example, Shannon modeled information in communication process as being transferred through a channel. Scholars, as their students who have been trained in this model since the 1950s, now consider this self-evident and obvious base on which to build virtually any discussion about communication, although communication scholars have gone far beyond Shannon's initial model. What are the differences between data and information? Here are the key differences between data and information. Data contains raw figures and lacks information, unlike data provides insights analyzed through the data collected. Information can't exist without bad data. Data doesn't rely on the information. Data as in through filtration process followed by a meaningful organization to generate output or information. Data process deliver into specific since there is rare relevant scattered among heaps of data unless processed. Information is particular with correlation to in inference derived. Data doesn't harbor any meaning, whereas information exists to provide insight and meaning.
Information technology systems, their role in converting data into organization knowledge. What are information technology systems? Information technology, or IT, is the use of computers to create, process, store, retrieve, and exchange all kinds of electronic data and information. ITs are typically used within the context of the business operation as opposite to the personal or entertainment technologies. Information technology systems means computing devices, calculating equipment, software, firmware, and familiar procedures, services including support services and related resources. Data versus information versus knowledge. Knowledge is an information process in the mind of the holder. They are personalized information gathered via study or experiences. Knowledge can also be viewed from the differential perspectives. Information is a message with the meaning that derived from the data, which is a set of plain, unfiltered, and objective records. So this is how you can establish the basis of the difference between data and information and knowledge. And the picture represents how data, information, and knowledge exchange each other. First, data is the one who processed and analyzed it, which is it reconstructed pictures of historical events or projection of possible future events. Then it exchanged into information, which is it internalized, absorbed, and understood by the human mind. Then it goes to the knowledge, which is externalized, verbalized, and illustrated. And then they exchange each other to capture and store. Another example in this picture, as you can see, data is the one who gives the facts to the information, which is it captures the data and it transferred to knowledge, but data can also be directly goes to the knowledge straight away without the help of information. Lastly, it ended to decisions where it informed the actions.
Data and information systems. How did it support collaboration and innovation to drive organizational success? The basic of information system. The term information system refers to any collective or equipment that makes it possible for an individual or organization to organize and analyze data. This means that the purpose of an information system is to collect raw data and transform it into useful information that an individual or larger entity can then use for decision making. A great example of commonly implemented business information system is a customer relationship management. Customer relationship management or CRM systems are designed to accumulate and track consumer activities such as how they first interacted with the brand, overall purchasing trends, customer inquiries, and much more. A robust CRM will both collect this data and then offer easy capabilities for businesses and organizations to analyze that data and make key marketing and business decisions off that data. For example, if a CRM shows a particularly strong response to a specific YouTube ad, the advertising and marketing department will likely focus on what made such a video successful and repeat the endeavor of a broader scale. What is information in business? Data is what translates to establishing information followed by strategic success. So, without data, the following steps won't exist. A good business stands on market analysis, gathered around data analysis that sieves the raw data for important insights. So, with information, exists a greater scope at deriving success in most business ventures. From data to information, and from information to business intelligence, every business relies on the data generated. Business are taking advantage of this process to create a difference in their market approach. Business information, like its other segments, is the information industry has several forms. Example, news, credit and financial information, market research, IT research, and industry analysis. They can further be categorized into directories, periodicals, stats, government information, guides, handbooks, almanacs, and directories. The internet has made it relatively easier for publishers to deliver business information, especially with subscription models that deliver content to their user base. Market research doesn't just stem from a linear source of data. It's rather an exhaustive process where analysts separate the good data, which is the cornerstone for any business strategy. Now, they will have business information systems that are designed to help organizations make important decisions via objective attainment. These systems uses the resource provided in most IT infrastructures to saturate the needs of variant entities existing inside a business enterprise. Five key components. The five key components of a business information system are decision, transaction, information, and function. You can really see the decision taking, rather that they are reviewed. However, transactions are more visible, but they are mostly processed through complex computer-based algorithms. Information and functionality can be observed since a workflow is established for these computers to comprise the business information system. Key ways information systems assist organizations. Seamless communication. A key component of organizational leadership and management is gathering and distributing information so that every position has the things that they need to succeed in their company role. Information systems assist in disseminating information by allowing managers and other organization leaders to store data in folders and documents that can be seamlessly shared with the appropriate employees. Most important information systems also allow users to communicate remotely so that no matter where an employee is, they can still receive information and react accordingly. More efficient operation management. Information systems enables organizations to collect and access recent information as well as keep a comprehensive collection of all organizational data. Combined, this enables businesses to operate more efficiently as things like real-time skills data offer insights into immediate customer purchase for better stocking or production practices. Better record keeping. No matter what, um, no matter what industry an organization is in, efficient record keeping is necessary. There are industry regulations that need to be adhered to and recorded proof those regulations have been adhered to. Then there is a long list of different financial records that are a component of every business. Information systems make record keeping easier, faster, and more accurate with features that enable document storage, revision histories, communication records, and other aspects of operational data. This type of recording keeping is not just useful for ensuring an organization stays within the necessary regulatory and financial lines, but it also assists business leaders in preparing cost estimates and making better forecasts to understanding how certain past actions influence operations. More informed decision making. This point bears the repeating as frequently information systems are used to inform the decision making processes that make or break an organization. Organization and business leaders must need the most accurate, up to date information if they are to make the best decision for the future of their group. Information systems not only offer past trends, but they also offer real time different business information and can be set to forecast future possibilities. Business leaders need all of the above in order to make the right decisions that will enable their organization to thrive. The conclusion. The conclusion in all this is that information science and technology have garnered potential traction in terms of technological transition. From servers to cloud to smarter databases, data is processed within a blink of an eye. With speed comes the ability to process data with even low-cost hardware units like SSDs or solid-state drives, HDDs, hard disk drives, and cloud services. Organizations are now storing heaps of data in hopes of processing them for insights that can help them drive organizational decisions or to predict future market dependability of their products or services. From medical science, education to space programs, to name a few. Data and information solve real life problems at breakneck speeds with their various applications. Virtually, there are no caps to their implications across industries and the benefit they harbor, respectively. And that is the reason for the demand for data analytics courses and professionals with data science skills is skyrocketing. So, to reiterate, these two concepts coexist to provide us with valuable insights that drive informed choices and successful outcomes. Uh, that's the end of the presentation. Thank you for watching.